So our temperature is a little bit over 40. It's about 42. So I've backed off a little bit on this to see if we can get that to come back down to 40. And while we're waiting for that, I'm going to measure out my cyclohexadiene. I've let it warm up a little bit so I don't get a bunch of moisture in there. And that's going to be into a nice clean 5 milliliter conical vial, and I'll cap that up with a septum, a rubber septum, so I can heat that and equilibrate it as well. So we're going to take my pipette and vial over. And it's going to be more accurate to measure this by mass than it would be by volume with a syringe. And we want to make sure that we have pretty close to exactly the 0.36 grams, 0.361 gram, I believe, is what we want of this compound. So we're going to add that dropwise. Through the top. And this is a really stinky compound. Alkenes smell very bad. So we're just going to drip some of that in there. Trying not to get it on the walls of the flask if we can. Definitely trying not to get it on the balance pan. .2 so far. We close the balance and we see that we are at 0.363 grams. That's pretty good. 0.363 grams. Put our tool in there. So I'm going to take this over to the hood. I'm going to add the 3 milliliters of ethyl acetate. Dissolve that. And put the septum on. And I'm going to just kind of swish that around to get that to dissolve. I can just evaporate. And we're at 44, which is hotter than I want to be, so I'm going to lower that a little bit more. Or alternatively, maybe I'll raise it a little more and I'll just run this at 45 degrees instead of 40. How about that? Hopefully we can get it to 45 pretty quick. So I want to get this at the same temperature as that, so that when I add them I don't change the temperature. Put the ethyl acetate back. Go grab my things from the balance. And this goes back in the refrigerator so it stays stable. cyclopentadiene does a spontaneous Diels-Alder reaction onto itself and can't actually be purchased as the monomer. You have to distill it from the dimer because the monomer is more stable. Cyclohexadiene will also react with itself over time. So we're getting actually pretty close to 45. I'm going to sink this now. Not all the way, but I'm going to kind of sink that down into the sand a little bit so I get that equilibrating at the same temperature. Kind of wiggle that back and forth. Scoop some sand around it. Shouldn't build up enough pressure to pop the septum off. We're getting pretty close to equilibrating at 45. I think that's going to be better. I'll just change my lab notebook to reflect the fact that we're running this at 45 degrees instead of 40. And the setting is about 60 on the dial for the 45 degree sand bath. So I'm going to be trying to collect data points. I'm going to collect one of the N-phenylmaleimide just so I know what its retention time is. And then I'm going to collect them at 2 minutes, 8 minutes, 14 minutes, so every 6 minutes basically. So I've already set this up. So I have 56A, that'll be my 0 minute, and then B through Q will be all the way from 2 to 92 minutes. I need a nice syringe. The one in there was kind of bent. So we'll see if this one is a better quality syringe. And I actually put away the ethyl acetate prematurely because I will need that to wash the syringe each time. I want a nice full bottle so it's easy to get the syringe in there. A little bit more full than the previous bottle. See, our temperature is almost there. Just a tiny touch. So I really want to make sure I'm exact. So while we're waiting for that, we can go and set up our GC for the run. We're going to be doing a single run and sample login. This is where I'm going to put my spectrum number, ECL10 56A-1, and the sample ID, T equals 0 minutes. Okay. There we go. And I gotta give it a data file. So I want to save this into my folder. Kinetics 2021. And I'm going to make the file name the same as the sample name, ECL-10-56A-1. I've put in the data description that I have the carrier gas pressure at 90 kilopascals, and I have the split open 6 turns, and this is the Diels-Alder reaction of cyclohexadiene and N-phenylmaleimide. So that's all set. And I can OK that. So each time I set up a new run, I'm just going to have to come in here and change the letter on both the file name and the sample name, and change the time under sample ID before I set up for the next run. So now I'm going to press this start button. That's going to send that information over to the GC. And it will say ready standby, which will tell it that I'm ready for an injection. Now I can go and get, using my syringe, some of my sample. Just going to rinse that a few times to make sure that the syringe is clean, since I don't know who the last person to use any of these was. It wasn't me. I'm going to be making 1 microliter injections each time. So we see we're very close to 45, just almost not touching it. So I'm just going to take that out, reach in there, pump it a couple of times, pull out my 1 microliter sample, and then I'm going to run that over to the GC. I need to push this down, depress the plunger. I'm going to make sure it actually goes in, pull it out, and press the start button in rapid succession so that I don't get a multiple injection. So it needed to go in at a little bit of an angle. Now that that metal has heated up, it's not going in quite straight. And then I'm going to just flush this with ethyl acid a few times to make sure my syringe is nice and clean. You'll notice it says acquire now. We're gathering data. To get a data point every 6 minutes after we add our cyclohexadiene to the N-phenylmaleimide and start the timer, we're going to have to be very quick. I'm actually not entirely sure the battery on my camera will last for that, but we'll find out. So we're acquiring data. You'll notice here is the solvent, ethyl acetate. That won't actually be being displayed because it's within my solvent cut time, assuming all went well and I have my settings correct, which is one of the reasons why we're running this. Because it's hard to get that split setting exactly the same from year to year. So it may be that my retention times are a little different. This peak here now at 1.5 or just a little less than 1.5 is probably the N-phenylmaleimide. And then we would expect our adduct to come off somewhere quite a bit later, but we're not entirely sure. Last time I was running these, my retention time on my N-phenylmaleimide was about 1.09 minutes. It looks like it's closer to 1.5. That's not a good sign. That may be enough to cause the adduct to not be on scale. Well, we'll find out in a minute. And at a previous time when I ran this, page 11. See what my retention times were. Run this reaction a number of times. Well, that's clearly it. And the run is over. So we could actually open that file in post-run. It's resetting. Open up the GC post-run analysis. And 56A-1 is present. So it looks like everything's coming off a little slower than it was before, because my solvent is not being cut off in that cutoff of 0.8 minutes, and this is coming off at a later retention time. So I don't like that. That means that I'm likely to not get my adduct off in the available time. So going back to real-time analysis, I am going to attempt to speed this up a little bit. So I'm going to go change this and do it again at 56A-2. Take a second spectrum, we'll OK that, and press the start button. We can press that start button even if this says not ready. It'll still go into standby mode. What I'm going to do to try to speed things up is I'm going to close down that split a little bit by turning that maybe a quarter turn. And what that will do is put a little bit more gas through the column, a little faster flow rate, and hopefully change those retention times to something a little bit more favorable. So it's standing by again. I can go get a sample. And we are pretty nicely stable at 45, just a little high. Give that a touch. See if we can get that down a bit. Just pump a couple of times. Pull up a microliter. Doesn't have to be exactly a microliter, but it should be close. And now, again, I'm ready to push that down and in. Gotta find the sweet spot.